Now, students, these are the topic tests that we have Bodhee Prep have for you for the quant section. Now, the idea of these tests is once you cover the basic concepts of a topic, you would want to test whether you're able to apply those concepts in an exam or not. That is when you pick up the tests for that topic. There are multiple tests available for each topic. Once you've gone through a test, that is when you refer to this video with the test, which this video gives you the solutions as well as a brief analysis of the questions that you should have attempted if you were actually writing a test and not just solving questions. There are more than 200 such topic tests available on the Bodhee Prep Android app. So make sure you download the app from the link given in the description below and make the most use of these tests. This test or this video is about the topic circles, and this is the first set test on the set topic. Overall, the test was easy to moderate level of difficulty, and about 6 to 7 questions would be required to get a high 95 plus odd percentile. The attempt time for this test will range somewhere around 20 to 23 minutes to get these questions, the 6 to 7 questions that we need correct. If you look at the questions, the first one says PQSR are points on the circumference of the circle of radius R, PQSR, such that PQR is a equilateral triangle, PS is a diameter. What is the perimeter of the quadrilateral? R is given, the small r is given to be the radius of the circle. Since PS is diameter, therefore we can say angle PQS will be equal to 90 degrees. This angle here, angle in a semicircle. And therefore, if you look at triangle PQR, triangle PQS, this is 90. This is given to be 30. Why is this 30? Because PQR was an equilateral triangle, and as we can see, triangle PQ, and suppose if this is or S, triangle PQS will be congruent to triangle PRS. Right, RHS congruency can be used. Since they are congruent, therefore these two angles will be equal. Hence, we know that angle QPS is 30. If one angle is 30, the other is 90, the third angle has to be 60. Now, in a 30, 60, 90 triangle, the ratio of sides opposite to these triangles is 1 is to root 3 is to 2. This is the standard for the 30, 60, 90 triangle. We know that the length of PS is the diameter is 2r. Therefore, the angle opposite 30 degrees should be half of that, which is r. And the side opposite 60 degrees should be root 3 of r, or the smaller side, which is root 3r becomes PQ. So PQ is root 3r, QS is r. As we said, triangle PQS is congruent to triangle PRS. PQS, PRS. Why will this happen? Because PQ is equal to PR, sides of an equilateral triangle. PS is common, and in both these cases, angle Q and angle R will be 90. So RHS congruency can be used, and therefore we can say PQ and PR equal, therefore this will be root 3R as well. And QS and SR equal, so this will be R as well. Therefore, the perimeter of PQSR simply becomes root 3R plus root 3R plus R plus R. This is twice 2 times R, 1 plus root 3. 2 root 3R plus 2R, which is option A, becomes the answer. At best, a moderate question should not take more than 2 minutes to solve. In the figure given below, SC is tangent to the bigger circle. SC is tangent to this is the tangent. AC is the diameter. There will be a center here of the bigger circle. What is the measure of QPR? This is the angle that we have to find out. Now, angle ACS will be 90 degree because the point of contact of the radius and tangent is right angle. Also, angle CAD will be equal to angle CBD, angle in the same segment. This angle will be equal to this angle, and therefore CAD is 60 degree. Now, if you look at triangle ACS, one angle is 60, one angle is 90. Therefore, angle SAC, angle ASC should be equal to 180 in a triangle ACS. 180 minus 90 minus 60, which becomes 30 degree. Now, if angle ACS is 30 degree, this is the same as angle uh, QSR. Also, if QSR is 30, therefore we can say angle QPR will be equal to angle QSR, angles in the same segment. And therefore, since this is 30, this angle here will be the same because it is on the same chord QR, and therefore we can say angle QPR will also be 30 degree, and that becomes our answer, option A. Again, easy question, maybe a minute and a half at most to solve the question. P is a point outside the circle with center O and radius 6. The radius is 6, OM is 6, OC is 6, ON is 6. OP is 10. Therefore, CP can be 4. 6 radius plus 4. So OP becomes 10. Tangents are drawn from P to M and N. Therefore, these two will be 90-degree angles. Angle at the point of contact. Tangent at the point of contact with the radius is 90 degree. The line segment OP cuts the circle at point C. There is another tangent drawn, so this will also be perpendicular. OC will be perpendicular to AB. This tangent meets PM and PN at A and B respectively. What is the length of the in radius of the triangle ABP? In radius of a triangle is given by, it is the radius of the in circle, simply area upon semi-perimeter. So we have to find the area of ABP and the semi-perimeter. Now, if we look at triangle, so we have to find PA, PB and PA, AB and PB. If you look at triangle PMO, this will be a right angle triangle, and therefore OP square is equal to OM square plus PM square. OP square will be 10 square is equal to OM, 6 square plus PM square. And therefore PM will come out to 8. 100 minus 36, 64. Therefore root of 64 is 8, or 8, 6, 10 is simply the Pythagorean triple that we have. Next, we also know that PM will be equal to PN. Tangents from the same point are equal. PM is nothing but PA plus AM. PM. PN is nothing but PB plus BN. Also, if we look at point A, AM and AC are tangents from point A. So AM and AC will be equal. Therefore, PA plus AC will be equal to PB plus CB. PM is equal to 8 that we have calculated, and therefore PA plus AC, PB plus BC will also be 8. And therefore we can say that the semi-perimeter of the triangle, which is A plus B plus C by 2, in this case for triangle PAB will be PA plus PC plus PB plus CB. That are the sides of the triangle. Therefore, 8 plus 8 upon 2, which is 8. PA plus AC is 8, PB plus BC is 8. So we get the semi-perimeter as 8 plus 8 by 2, which comes out to 8. Now we have to look for the area of the triangle PAB. For that, what I'm doing is I'm looking at triangle ACP. PC we know is 4. PA plus AC we know is 8. So if AC is X, PA will be 8 minus X. Also, this will be right angle triangle because point of contact of the radius and the tangent. So here we can write AP square is equal to AC square plus PC square, which means 8 minus X whole square is equal to X square plus 4 square, which means 64 plus X square minus 16X is equal to X square plus 16, which gives us 16X is equal to 48 or X is equal to 3. This means this is 3. Therefore, this is 5. So now if you look at triangle PAB, PA is 5, PB will be equal 5, symmetry. AB will be AC comes out to 3. So CB will also come out to 3. So A plus B will come out to 6. We have to find the area of this triangle. We draw a perpendicular from P to AB at say D. Therefore, AD and DB will be 3 and 3 because it's an isosceles triangle. Perpendicular will bisect the base. Using Pythagoras theorem, we can say that this side PD will be 4. So area of this triangle is simply half into 4 into 6. PD becomes the perpendicular 4, AB becomes the base 6, and therefore 8 to 6. Area of the triangle will be 6. So if you look at the in circle, it will simply be half into 4 into 6, sorry. 6 twos are 12. Area will be 12, semi-perimeter is 8, and therefore the required in radius will be 1.5. I will call this a difficult question. There are multiple steps that are there, and making the triangle again and again, and then getting the side. So this question will take some time, about 3 odd minutes to solve the question. In the adjoining figure called ED is parallel to diameter AC. These two are parallel. If CBE, this angle is 65. What is the angle of measure DEC? This is to be calculated. So we have the diameter. EBCD. So what we can do here is, if we join AE, and therefore what happens is, this angle here becomes 90 degree. Angle AEC will be 90 degree because it is in the semicircle. AC is the diameter. Also, angle EAC will be equal to angle EBC. Angles in the same segment. EBC, EAC. And therefore, angle EAC will be 65 degree. Now, in triangle AEC, one angle is 90, one is 65. And therefore, we can say angle ACE will be equal to 180 minus 90 minus 65, which will come out to 25 degree, 155, 25. Also, on sides AC and ED, which are parallel, we have a transversal CE, and therefore this angle is equal to this angle. Alternate angles or interior angles on both sides of the transversal, they have to be equal, and therefore angle ACE will be equal to angle CED, which we had to calculate, or DEC, and therefore this is nothing but 25 degree. Option D becomes the answer. A relatively easy question, about 1.5 minutes to solve. A circle with radius 2 is placed against a right angle. This is the larger circle. Another smaller circle is placed as shown in the adjoining figure. What is the radius of the smaller circle? Now, for questions like this, it will be the standard process. We will draw a line from the center of the circles to the corner, which is here. And then perpendiculars from the center to the other side. Now, if this is O the center, this is O dash the center, this is A, this is B. The point where the perpendicular from the center to the base meets for the two circles are A and B respectively. Now, and this corner here is C. In triangle O dash BC, we can see that O dash B will be the radius, which is R. Suppose the radius of this smaller circle is R. BC will also be equal to R because this length will be equal to the distance of the center from the other side, which will be true for the smaller circle as well. And therefore, we can say that O dash C is nothing but root 2R, because we have a right angle triangle with two sides as R. Therefore, the third side has to be root 2r. Use Pythagoras theorem if not able to put this directly. Then we look at triangle OAC. Here also, OA will be the radius which is 2. AC will be the radius which is 2. And therefore, we can say OC should be nothing but 2 root 2. If this is 2 and this is 2, the diameter, the hypotenuse will become 2 root 2. But we know that OC is equal to, suppose the intersection point of these two, or the point where these two circles touch is D. OC will be OD plus DO dash plus O dash C. OC is the radius of the larger circle. OC we have found out is 2 root 2. OD is the radius of the larger circle, which is 2. DO dash is the radius of the smaller circle, which is R. And O dash C has been calculated as root 2R. And therefore, we can say root 2 plus 1R is equal to 2 root 2 minus 2. And therefore, R is nothing but 2 root 2 minus 2 upon root 2 plus 1. We rationalize this by multiplying by root 2 minus 1. So 2 into root 2 minus 1 into root 2 minus 1. I'm taking the 2 common from here, so root 2 minus 1 is left. And the second root 2 minus 1 is because we are rationalizing by multiplying by the conjugate. So in the numerator, we have, this is a minus b whole square. So root 2 square, 2 plus 1 minus 2 root 2 upon a plus b into a minus b, which will be root 2 a square minus b square. Therefore, we'll have 3 plus 2. 6 minus 4 root 2 upon 2 minus 1, which is 1. And therefore, this becomes the radius of the smaller circle, option D. Now, this is the standard process for questions like these. The line joining the center to the edge, the corner will become root 2r times. And then along the radius, we keep adding to find the unknown variable. Medium level of difficulty at best, about 2 to 2.5 minutes to solve once you know that the process is standard. On a semicircle with diameter AD, chord BC is parallel to the diameter. Okay. Further, each of the chords AB and CD have length 2. AB is 2, CD is 2, length of AD is 8. What is the length of BC? Let us draw perpendiculars. If I drop a perpendicular from here and a perpendicular from here, so this is E and F. If you look at BCFE, BC and AD were given parallel to us. Also, EB and FC will be parallel to each other because they are perpendicular to the same line AD, and therefore BCFE will be a parallelogram, and therefore BC will be equal to EF. Further, if we look at triangles BEA and triangle CFD, BE will be equal to CF because they are sides of a parallelogram. AB and CD are given equal in the question, and both these angles are right angle triangles. So they will be congruent basis RHS congruency. And therefore, we can say AE is equal to FD as well. Next, I'm joining B and the center. Suppose the center here is O. Now, OA will be 4 because AD is the diameter, half of AD will be the radius OA, which is 4. If we take AE as X, EO becomes 4 minus X. We are taking BE as Y. Now we have two right angle triangles, triangle BEA, where we can write AB square is equal to Pythagoras theorem x square plus y square, which means 4 is equal to 2 square is equal to x square plus y square. Second, in triangle BOE, we can write OB square, which is the radius, will be equal to y square plus 4 minus x whole square. This triangle and this triangle, I'm applying Pythagoras theorem. OB square is 4, so 4 square is equal to y square plus 16 plus x square minus 8x, which means 16 is equal to y square plus x square plus 16 minus 8x. X square plus y square we know is 4, so 16 and 16 cancel. We can say 0 is equal to 4 minus 8x, which means 8x is equal to 4, or x is equal to 4 by 8, which is 1 by 2. So if this is 1 by 2, FD will also be 1 by 2 because AE and FD are equal. So we can say EF will be nothing but AD minus AE minus FD. AE and FD are half and half. AD is 8, which means EF comes out to 7. We know that EF and BC were equal, so the length of BC also becomes 7. Option B becomes my answer. I think a moderate sort of a level question, 2.5 odd minutes to solve the two quadratics, or rather the two Pythagoras theorem that we are solving with two variables. Two identical circles, so basically they have the same radiuses, intersect so that the centers and the point at which they intersect form a square. The centers will be outside. The point will be outside the intersection area, because when the centers are on the circumference, the angle formed is 60 degree. Something like this. These are the centers O and O dash. These are say the intersection points A and B. Square is formed, so all of the angles are 90 degree. Also, AO is equal to AO dash is equal to O dash B is equal to OB and so on. The side is 1. This side will also be the radius the radius of the two circles. The radius of each circle is also 1. The area of the portion that is common to the two circles. So we join AB and try to find the area of this segment here, or sector, whatever it is. Right? So this will be nothing but we are trying to find the area of this segment here. This will be area of sector AOB minus area of triangle, area of sector AOB minus area of triangle AOB. Since this is a square we have formed, so the angle at the center will be 90 degrees. So 90 upon 360 into pi r square, which is pi into 1 square minus area of triangle AOB will be, since this is a right angle triangle, it will simply be half of OA into OB. OA and OB both will be the radius of the circle, so 1 and 1. So this becomes pi by 4, 90 by 360 minus OA is 1, OB is 1. So 1 by 2. This is the area of the segment on the right. Same will be the area of the segment on the left, and therefore the total area will be twice of this. So the area common is simply twice of pi by 4 minus half, which will come out to pi by 2 minus 1. Option B becomes my answer. Again, these are common questions, and therefore you would have come across similar questions while practicing. Therefore, I'm saying moderate, about 2 minutes to solve. 4 points A, B, C, and D lie on a straight line in the xy plane such that AB is equal to BC is equal to CD. 4 points lie on the xy plane such that AB is equal to BC is equal to CD, for example. A, B, C, D. And the length of AB is 1, so all of them are 1. An ant at A wants to reach a sugar particle at D, but there are insect repellents at B and C. So there are repellents here. We have to travel from A to D. The ant would not go within 1 meter of the insect repellent. So if we look at the effect of this repellent, it will be a sort of a circle. 1 meter around B is something that the ant cannot go into. Similarly, from C, there will be a circle formed. Cannot go within this circle, assuming that this is actually a circular shape. The ant cannot go within these circles. It has to just start from here, and travel around to reach D. The minimum distance the ant must travel. So how the ant will travel? It will start along the circular region here, go until a point from where it can go on a tangent route and a straight line to this circle, and from there cover along the circle again. So if we look at this, due to symmetry, you'll realize the ant will travel one fourth of the circumference of the first circle, then a straight line which will have the same length as BC, and then again one-fourth of the circle here. And therefore, the total distance that the ant needs to cover will be the radius of both these circles is 1. So one-fourth of pi of 2 pi r plus BC length is 1 plus one-fourth of 2 pi r. Again, r in both cases is 1. So one-fourth of 2 pi plus 1 into one-fourth of 2 pi. This is 1 by 2, 1 by 2, and therefore pi by 2 plus pi by 2. So pi plus 1 is the total distance that the ant will have to cover. It will be the blue route, one-fourth of the circle along the first circle, straight line BC, and then the remaining one-fourth along the second circle. Again, I think moderate-ish level of question. Once the figure gets in place, solving it will not be that difficult. About 2.5 minutes to solve. The following is the diameter of the circle is 3 centimeter. Diameter is 3. Okay. AB and MN are the two diameters, and therefore AB and MN are 3, such that MN is perpendicular to AB. So this will be 90 degrees, and this will be the center. So AB and MN both are 3. In addition, CG is perpendicular. CG is perpendicular to AB. This is also 90 degree. Since CG is perpendicular to AB, MN is perpendicular to AB, therefore CG and MN will be parallel. Also, AB is such that A is to EB is 1 is to 2. AB is a diameter with length 3, so we can say A is 1, EB is 2. Splitting 3 in the ratio 1 is to 2. So A is 1, EB is 2. DF is perpendicular to MN. DF is perpendicular to MN. This is also 90 degree. DF perpendicular to MN, AB perpendicular to MN. Therefore, DF and AB will be parallel as well. NL is to LM is 1 is to 2. NM is a diameter of length 3. 1 is to 2 means this is 1, the remaining part is 2. We have to find the length of DH. Now, if we look at the radiuses OA and ON will be the two radii, and they will be of half the length of the diameter, so 1.5. OA is 1.5, out of which A is 1. So OE becomes 0.5. OL also becomes 0.5. Also, EH is parallel to MN because these two lines are parallel. BA is OE is parallel to LH because these two lines are parallel. Therefore, we can say OELH is a parallelogram, which implies OE will be equal to LH. Since OE is 0.5, LH will be 0.5 as well. Now I am joining OD. Now triangle ODL will be a right angle triangle with OD as the radius. So we can say OD square is equal to OL square minus LD square. The moment we get the length of LD, we can subtract LH from there to get the length of DH. OD square will be OD, the radius, 3 by 2 whole square. OL square I'm writing as 1 by 2 whole square minus LD square, Pythagoras theorem. Therefore, LD square will be 9 by 4 minus 1 by 4. 3 by 2, 9 by 4, 1 by 2. LD square comes out to 8 by 4, which will be nothing but 2. Therefore, LD is nothing but root of 2. LD is root of 2, out of which LH is 1. So DH is nothing but LD minus LH. LD we have calculated as root of 2. LH we have calculated as 1 by 2. This becomes 2 root 2 minus 1 by 2, which is nothing but option B becomes my answer. Again, because the figure is very, very symmetrical, that is the only reason I'm saying maybe an easy question. There are parallel lines, perpendiculars, or right angles can be formed, and therefore I'm saying conceptually maybe towards easy. Solving time might go up to 2 to 2.5 minutes because we'll have to solve at least one Pythagoras theorem will have to be solved at least. The attempt time might be higher, but conceptually I'm saying easy. A semicircle is drawn with AB as its diameter from C. Okay, so semicircle is drawn with AB as its diameter, assuming this is a semicircle and this is the diameter AB. From C, a point on AB, a perpendicular to AB is drawn to meet the circumference of the semicircularity. AC is to CD is 6, the area of the semicircle. So suppose this is the point C, we draw perpendicular meeting the semicircle at D. AC is 2, CD is 6 is given to us. We have to find the area. So again, in questions like these, what you do is you join this point with the center. Suppose the center is 1, the radius of the circle is R. Now OD and OA, both will be the radii, R and R. AC is 2, therefore we can say OC will be nothing but R minus 2. We get a right angle triangle ODC, where we can use the Pythagoras theorem and we can say OD square is equal to CD square plus OC square. R square is equal to 6 square plus R minus 2 square. R will therefore come out to 10. R square is equal to 36 plus R square plus 4 minus 4R. R square cancel. 4R is equal to 40. R is equal to 10. The radius of the circle is 10. The area of the semicircle will be half of pi R square, which is nothing but 100 pi by 2 or 50 pi becomes my answer. I think relatively easy sort of a question, maybe 2 minutes to solve. So if you look at the overall test, it had quite a few easy questions, and therefore I'm saying attempt should be higher, about 20 to 23 minutes. And if I had to find myself 6 to 7 questions, where would they be? For me, they'd be 1, 2, 4, 5, 6, 9, 10. Which are these? Definitely doing this 30, 60, 90 triangle easy to spot. This again was not very difficult. The figure looks a little intimidating, but all we had to do was find one angle, and from there it kind of followed. This question again might not happen every single time, especially with in radius given and all of that. I am not counting it as a exam question for myself. This was a simple question, probably one of the easier ones in this test. This is again a standard format question. Repetition is very high for this kind of a question, therefore counting this question as well. Again, Pythagoras theorem, I think manageable, so I'm counting this as well. If you are comfortable with these questions, you would count them. I'm not counting this question as the easier of the 10 for the simple reason that angles keep changing, the intersection point keeps shifting, and therefore the answer keeps changing a little bit every single time. So if you've done it, great. I'm not counting it. This is an exam question. This again, not something that might happen for the first in the first attempt because the figure needs to be drawn. If you get the wrong figure, it is not happening. So not counting this as well. Here again, as long as the parallel lines and the scope for Pythagoras theorem, I think the question remains easy. So counting this question as well. This one also, even though the figure is not given, it's a standard process question where we are joining the center with the circumference and then forming a right angle triangle with the radius. Therefore, counting this as well. So 1, 2, 4, 5, 6, 9, 10 would help me get my 6 to 7 questions net correct.